Okay, I'm going to give a quick walkthrough of assignment 6 and also the participation requirements for this week since they're so closely tied together. We're going to be looking at these convolutional neural networks for image processing, and we're going to look at a set, a well-known test set of images. CIFGAR 10 is a set of images, 60,000 images, each 32 by 32 color images, and are broken into 10 classes. So here's an example of this, and it's actually part of a larger data set out there of 8 million images, but this is something we can at least test on in class. So these are 32 by 32-bit images. They're color, so there's red, green, blue, so 3 layers of color here, and they're images of dogs, of deer, cats, cars, airplanes. So there's 10 different categories, boats, and so the task is to look at these images and recognize that's a dog, that's a horse, that's a boat, that's a truck, that's an airplane. So that's what we'll be training a network to do, is try to figure out which of the 10 things each item is. We're going to use this convolution neural network in JavaScript code. Just going to pause this real quick and go over it. So here's where we set up our network. There's a default network that's set up here, but we can actually just change this in different ways. And then it actually shows the images. Let me run this again. So it'll show live. Here's the image that it's looking at. So here's a truck, and here's each layer, layer by layer, layer by layer, and finally it gets some output here. So it also will show some predictions. So at the very bottom, it'll show the last 200 predictions. So it looked at this image, and this shows that it thought possibly it was a car or a ship or an airplane. An airplane, since this bar is larger, is most likely. So it predicted this was an airplane. The green actually shows what it is. This is actually a ship, which is second place. So again, it looked at this and thought it was either an airplane, deer, or a horse. It's neither of those. And so it was wrong. And again, we haven't trained this much, so it's not very good. And then eventually, hopefully, these networks will get better at these sorts of things. Okay, so your job is to run 3 different training sets on here, 3 different types of networks. Well, I mean 4. 1, 2, 3, 4. The first is just a traditional 3-layer network that we're going to set up. So this describes how to set this up. So if we look in, again, in our demo here, this is where we're going to put in that code. And you can actually just copy this code out and paste it in here and hit change network, and it will then update the network to use that. You might have to hit, I usually pause this, paste it in here, hit change network, and then resume, and it'll start all over again with this new network configuration. So let's look at this. The first network we're going to use is just a 3-layer feed forward fully connected network, what we kind of looked at last week. So we have some input images. These feed forward to 20 hidden units. And I'm drawing this, usually I draw this with the input at the bottom, output at the top, but I'm switching because this kind of matches what we have here. We're first going to push, we define our layers, an array that is going to hold all of our layers, and then we push new layers onto this, and so we kind of stack them up. So the first thing we push is this input layer, and its size is 32 by 32, and its depth is 3 for red, green, blue. So this, and you always have to have this as your first layer with this, because that's the images that are coming in. So that's what we have here. Imagine these were 32 by 32 pixels. And again, there's red, green, blue, 3 color layers. Okay, then we're going to push in a fully connected layer of 20 units here. So here's our 20 units. and then we're going to push in another fully connected layer of 10 units. That means every unit, every cell here is connected to every cell here, and again this is fully connected, so every cell here is connected to every cell here. And in each of these, our activation function is going to be tang h, the hypertangent function, which is one of these sigmoid curved functions that we looked at last week or last unit. Okay, then we're going to do a categorization unit called softmax. And that what that does is we don't know what these activations are going to be exactly. Some of them might be large or small or whatever. This converts it into a list of like percentages. The total of all these will be 1, and so some of these will be higher percentages and some will be lower percentages. I'm not going to go over the math of that, but basically that just converts this into a prediction percentage, where each output here is the percent confidence we have that that is the right object. So we generally finish with, in this case, always a softmax with 10 classes that we're kind of classified, because there's 10 different types of images in this sample set. And then don't worry about this. You always have to do this. You have to do some training, and you have to use some. You have to actually set up the neural network. So again, the two things in bold are basically the two things that we're adding here that we can change each time. Now, if you want, there's nice documentation here describing this, the different types of layers, the input layers, the fully connected layers, and you can do sigmoid, tang h, or this rectified linear units as we go. And then we'll look at some of these convolutional networks options in just a sec. So we'll run this. Now on each of these I want you to run it, let's see, what did I say? I think 30,000 times. No, I want you to look at least 40,000 images. So there's 60,000 images, but 10,000 or 50,000 are set up for training, and then 10,000 are set aside just for testing this out and not trained upon, because we don't want to just memorize what all the images are. So if we run this, it'll run this beginning simple network. You should be able to get up to 40,000. Here's the example scene. This is what you want to get up to 40,000. It should take about 5 minutes to get up there. So just set this running. And you can use this default configuration, at least for the first one. And again, so then we're going to want to watch the training accuracy and the validation accuracy as we go. So this is just how accurate we're doing on the training images and how accurate we're doing. And usually we're more accurate on the training than the validation, but in this particular case, we're right now more accurate in the validation. So what this means is that we're getting it right almost 40% of the time, 38% of the time we're getting it right. And if we go around here and look, well, I should back up. So when we're looking at images that we're training on that we've seen before, we're about 34%, and we're doing validation, we're seeing 38%. Now one of the reasons is there are 50,000 images and we've just seen 51,000, so we really haven't seen it's not like we've seen every image 10 times. So if we let this go through 1,000,000 times, or then our training will memorize these images better, and we might and that training accuracy will creep up and will be higher than the validation accuracy. Validation is on these images that we've never trained on, that are kind of unique, and see how we do with that. So we generally want to report both of these results, but the validation one is probably a more meaningful one. And again, we can look back here. So again, here's our network. We have our inputs, 32 by 32 by 3 for RGB, a fully connected layer. This just shows kind of the activations of the connections. And here's our tang H layer and the activations there. Those are our 20 hidden units. And here's our 10 hidden units, and then here's our softmax, which we're predicting. And so yeah, we can kind of see the results here. I think this is a bird, a dog, or cat. It's pretty close on all of these, equal there, but bird won out. Saw this, thought it was either a frog, a bird, or a deer. It was a deer, but it thought it was a frog. But it gets a brown. It could be same here. Thought this was an airplane. It was really a car. But again, about a third of the time, about 38% of the time, it's getting it right. Figured out that's a dog. Again, with this simple sort of network, it's often just memorizing colors and simple things like that, and not doing anything too complicated. Learning that red things are maybe often trucks, and so it's got that right. So run this and record that. So again, I've run this for 50, but you have to just make sure you get to 50,000 units. 40,000 example images that we want to run each of these through. Yeah. Okay, so run this traditional network. And in each place, what we want to submit just your results, the network configuration you used, and the training and validation accuracy. And so, like in this case, you just used this default network. Unless you want to change this, unless you want to change the number of hidden units, or maybe the activation. So feel free to try, just paste this right in, or else try maybe more hidden units, maybe that's because we're not getting really good results with this, but we won't with just a 3-layer network. The other one we're going to look at, the next one, is just a convolution network, where we've got our inputs, we got a convolution, and then a pooling to make the images smaller, and then our softmax to predict the results. So we can see like this is, we might have our input image, and then what we're going to do is convolution is grab a filter, maybe a 3x3 filter, and lay it over all these images to get some new results. And we might have different filters, so we might have 4 different filters that we'll try out and work. So again, in each 3x3 areas resulting in 1 pixel here. We'll shift it over us maybe 1 or more pixels. That's called our stride, how far we walk it over each time, and lay it down, and then generate another pixel, and lay it down and generate another pixel. So when we look at this type is convolution. That's the type we're looking at. The size, the SX is the size. 3 means it's a 3x3 filter. The number of filters, 4, is the depth. How many different kinds of filters we're going to use? Like here, 1, 2, 3, 4. So maybe a vertical edge detector, a horizontal edge detector. We don't specify them. It learns what works, but it'll have 4 different types of filters, which isn't very much, but is a good start. The stride is 2, and the padding is 1. Padding's not that important. It's just the 0 padding around the edges. The stride is how much we do. So here we'll lay this over here, and then we'll shift it over 2 pixels, and then the next one will go right here. Having a stride of more than 1 makes the convolution smaller. So it shrinks it in half, because every time, rather than moving over 1 pixel, we move over 2 pixels. And so we generate 1 pixel here for every 2 pixels here. So a stride of 1 is more common, but in this example I just put 2 to try out a different thing. And then pooling, this is again where we're pooling these images down. This is a 4x4 pool. It uses max pooling. So again, we're looking at 4x4, so something this big, finding the largest value in there, and then we'll just get 1 pixel from that. So this shrinks it by a factor of 4 down here when we run this. So again, you can just start up our network. I'm just going to pause this. You can grab this network. And now I encourage you to try to make some changes to this, try to improve it subtly in different ways, but still stay with this basic network structure. I'm just going to erase everything here and paste this in here. And again, so maybe I want you to just leave it with 1 convolution and 1 pooling layer, but maybe try some different things here. Maybe try different sizes or some different filters. So that, again, these 2 lines, the 2 lines that you can look at and changing maybe different stride sizes, and try those. So once you get that set up here, we hit change network. It will change the layout of the network down here, and then we'll hit resume. I think it actually only updates the pictures after we hit resume, and then it starts classifying these. And it should go relatively fast because again, this is a relatively simple network. So far we've only looked at 2,000 images, but again, it should perform pretty well as we go. But it won't get top performers are 80 to 90%, and we're only at 20% here. So let that run for 40,000 and report your results. And again, what changes did you make to these bold areas in each place, and then what results did you get? Okay, the third thing we're going to look at is the default network here. So I'm going to close this one up. Now, when you start this up, there's a default network in place. So we start with our inputs. We have a convolution with filter size of 5, 16 different filters, layer size, and a stride of 1. And again, linear rectified units. And then we pool them down in half, size of 2. We'll pool things in half. And then again, we do another filter with size 5 and 20 filters here. And we pool them down in half again, another filter size, and then we pool, and then softmax. So that's a 3 convolutions and 3 pools in here. No fully connected layers here, so not a fully connected, no fully connected or hidden layers here in this default example. And so you can run that. Now this is starting to run a little slower because it's getting larger. So here's our image in the first convolution. Here's the next, and here's the pools. We're getting smaller images, another convolution, and pools, another convolution. And so now again, we're getting a lot more and more images here, but they're just smaller. And then we're doing our softmax, which does our predictions at the end. So again, let this run. It's going to run a little smaller here. So you might just have to let this run for a while. See if you can get it up to 40,000 on your computer, and see what you get again for your accuracy as we go. Okay, so those are the 3 easy ones. Now the fourth one's a little more challenging. You've got to decide your own network configuration that you want to use. See if you can get, like a validation accuracy above 70% is really good. So if you can get that, that's really good. So no, I don't have too many guidelines to this. You can look at what they talked about in the lectures where, again, we did a number of convolution and pooling layers mixed together, and at the end we did a layer of a fully connected layer or 2. So we didn't do any examples like that, so that's a good example to start or to try something like that. But you're free to try any sort of network that you want to here. And so to kind of help each other out, your participation activity this week is to post for this, post your network configuration file. You just copy that, a paragraph describing what it is. So make sure we all understand what you're trying to do and what you're doing, and then the results, both of the results of the activities. So the validation accuracy and the training accuracy of your results. So post those to discussion areas, and then feel free when you're creating yours just to look at what everyone else is doing. And if someone's doing well, feel free to grab their network configuration, tweak it a little bit, see if you can improve their results, and we'll see if we can together as a class build the best network. And again, you don't have to take someone else's network. If you have a fun idea you just want to try that and post the results you get. But we want to try to see as a class how good of results we can get as we go there. So another quick point is that there's a pre-trained, preloaded network with 80% accuracy that you can load up here. You're welcome to look at that and see what that is set up to if you want to get a peek. So, okay, and for your assignment, just submit your results. The network configuration, again, you can just copy and paste these network configuration files in here, and then your training and validation accuracy. Now, I think this is relatively clean and straightforward assignment. Running it takes a little bit of time, but it's not too much there. And you might be wondering, why is this assignment? And that seems nice. Just a quick reminder, next unit, we have a quiz coming up. And so if you have a little extra time, it's worthwhile to jump ahead and start studying for the quiz. The quiz one study guide is up here, and you can go and look at that. So part of the reasons this assignment's a little less than some units is to give you time to start looking at the quiz that's available in the next units. Okay, have a good week.